Hello, welcome back to part 2 of assembly in Creo. In the first video, we were able to successfully import our gear and mount it on a shaft, which is a part of the back plate. Now what we want to do is to add a key in the key slot that we have in our gear. If you remember that you made key slots in your gears, and this is not the simplest way of doing this, but just to showcase how you can edit features, edit existing parts, and make new parts within Creo assembly. We'll do that within this assembly file. So right now we have two parts. We have the back plate and the gear. I will now create a new part, which would be my key, but I'll create that from within Creo assembly. I won't go out, make a new part file, and then come back. And the reason I won't do that is because I want access to dimensions within my assembly and create parts accordingly. For that, I'll go to the model tab in Creo assembly and select the create option. So this is create. I'll select create, and this menu pops up where it asks you what kind of feature do you want to create. I want to create a new part. This would be a .prt file. I want to call it key, and I want to create new features. So from this second menu, select create features. And now you see that a third part in your assembly has been created, and that is the part which is active. So the background parts have been grayed out, and now you can start modeling things here over here. What I want to do is that I want to make a square extrusion, and I'll use this plane as my starting plane. So I'll select that plane, the face of the gear, to make a new extrusion. Because we're working in assembly, we need to provide some information about what datums can the new what datums will the new part reference. So we need to select two planes or two edges from existing features in our Creo assembly that intersect. So I'll select this plane and this plane. They're intersecting features, and that satisfies the requirements of referencing within Creo assembly when you're creating a new part within Creo assembly. And now, just like extrusion I've done, just like sketching that we've done in the past, we'll use these tools and we can make a rectangle over here. And when I click OK, that would be extruded. But I'll also use this opportunity to showcase a command within Sketch that we haven't used in the past, which is offset. It's similar to project. Sometimes you have features in the background that you want projected onto your plane of sketching, but sometimes you might have features that you want copied, but you want them copied or recreated at an offset. They can be copied from features that exist in different planes or different sketches or from the same sketch. So I'll use offset once, select offset, I'll select this plane, and now Creo is creating a second line at a particular offset. I'll make the offset be 0.71 for now. I'll change it later. I'll change it to minus 0.07. Minus means that it's on the inside. So in this way, I've been able to create a line, a feature which is identical to the existing feature, but at an offset. I actually want this to be much closer to this edge. The reason I'm not projecting it is because the key has to be slightly smaller than the key slot for it to be inserted. So for that reason, I'm not creating it exactly along the dimensions of the key slot. I'll get rid of this project option to show you another way how you can use the offset. Select offset, select the first line that you want to be recreated at an offset, and then while holding down shift, if you can select multiple lines. And now I've recreated this edge at an offset, this angle, edge of the rectangle at an offset of 0.1. So you could use this offset functionality, which is very good, useful functionality to create concentric circles. You can create rectangles within rectangles, rectangles outside of rectangles, uh, and just create any entities which are identical to existing entities but at a distance. I'll make a line over here. Actually, I'll extend this out. I'm not being very particular whether this is a square or not. I'll pull it out to what seems like 0.1 mm and complete my rectangle. I'll get rid of this edge and I have a closed square or rectangle. When I select OK, I can extrude that out. I actually want that extruded in the opposite direction. I'll extrude that in. I know the depth of my gear is 10 mm, so I'll make this key 10 mm deep. I'll select OK. I'll activate my assembly, and now you see that you have a new feature, a new part which is key, and you can open it and modify it from here if you want as well. So for example, if I wanted to, I could chamfer these edges, and that should be reflected in the main assembly file as well. If you look closely, these edges are now chamfered. That's how you can create new features within Creo assembly. And another useful way of using existing parts in Creo assembly to modify other parts is by performing boolean operations. If you go to components and then select component operations, you can still perform a different variety of operations. We'll only look at boolean operations. And if you remember one of our first lectures about primitive CAD modeling, we took a look at how different primitives were assembled together either by simply adding them together using union, using intersections, or by performing different Boolean operations. So that's what we'll do over here. So we'll perform a Boolean operation between the key and the shaft, and the goal of that is that wherever the key is entering the shaft, we want that part to be hollowed out. Because right now, if I take a look at my shaft, it's a complete cylinder, and that's not practical. For the key to go in, there has to be a key slot. I can make an extrude over here, remove material, or I could perform a Boolean operation, component operations, Boolean operation. And now you have to specify two parts, the part which will be modified and the part which will be used as a pattern to perform the modification. So the modified part that I want is my shaft, which is a part of my backplate. So the base, what's the name of my backplate of my shaft? That's the feature that I want to be modified, and the modifying component in this case would be the key. And the type of Boolean operation that I want is a cut, so a subtraction. I want that part between the two which are intersecting to be cut. When I select cut and click OK, now if I, let me see if that has been performed. It should have been performed, but it doesn't. Okay, yes. So it has been performed, and if we see over here, we can't tell, but there should be a hole within our shaft. So let's look at our shaft over here, and at that particular orientation, the key is cutting over here, and we have a hole which has been made, which is identical in dimensions to the size of our key. In this way, you can modify existing features using the dimensions of other parts in your assembly. So if I, let's say, hide, I don't want to hide actually my shaft, I'll hide my key. If I hide my key, I'll also hide my gear. You see that there is a hole which has been cut where the key sits. Alright, so in this way we've been able to um, create new parts within Creo assembly, and you can work on those parts outside of the assembly as well. But sometimes this might lead to problems if the part that you created used references, and most of the cases it does, which are references from the assembly. And if something changes in the assembly, then that would corrupt or at least modify parts that were made using references from that assembly. So it's okay to use this functionality of creating parts within assembly, but to the extent possible, avoid doing that, create parts separately and then import that. Next, what we want to do is to add a second gear over a shaft. This time around, I won't make a shaft as a part of my original part. I'll import a shaft which I've already made. So I made this shaft and I'll assemble that. Now, while assembling it, I'll use this separate window command. This is what the shaft looks like. I want this face of the shaft to be coincident with this face of the back plate, but in the opposite direction. So now I've constrained my shaft to be coincident with this back plate. It can still rotate, but that doesn't really bother me. And the next thing that I want is for it to be fully constrained, and I want it to be along the same length, uh, along the same height as this shaft. Again, I'll leave that the shaft partially constrained right now, and what I'll do is that I'll open this backplate part in a new part file, and I'll create a new plane that cuts through the center over here. Hopefully in a few minutes the reason for doing this will make sense, but right now just focus on how we can make a new plane. We want to make a new plane that is parallel to this plane and is coincident to this axis. So you'll select those two components, and then from datum, and we're working in a part file right now, you can make a new plane. Right now this plane is being made at 0 angle, so it's being made parallel. If you wanted, you could have the plane be at a particular angle as well, but we don't want that. We want it to be parallel to this plane and passing through this axis. And we'll create another plane as well, which is perpendicular to this axis and passing perpendicular to this plane and passing through this axis. So I'll select this axis, this plane, make a new plane, and I want it to be perpendicular. And purely cosmetic, but instead of having the plane be this big, when you're creating a new plane, you have the option of selecting how large or small the representation, the icons for that plane be. So what I did was that I went to display. Instead of using the display reference, I unchecked that and I changed it to a more manageable size. I can do that for the old plane that I created as well. I don't want it to be this big. I know that this is a plane that refers to this shaft. So for that purpose as well, it's easier, it's helpful if these two planes are close to that shaft. Now you see that these two planes have been created, and what I want to do is that I'll go to this a new shaft that I'm trying to assemble, and I'll select this plane, the reference plane of that shaft, and a reference plane of the old shaft that I just made, and I'll make them parallel. I'll add a new constraint where I'll select perpendicular planes to those two planes that I just selected, and I'll make them coincident. And what is the advantage of doing this is that now uh, this plane is at the same height, this shaft is at the same height as the new shaft, and uh, this parallel constraint doesn't really help us. We'll actually convert it to a distance constraint. If I have a distance constraint, I can change the distance between this shaft, and I want precise control over what this distance is. And the reason for that is that the distance between the centers of two mating gears should be at least equal to the diameter of the pitch circle. Because remember, two mating gears have, or the sum of the pitch radii, two mating gears have their pitch circles tangent to each other. So I want this distance to be, in my case, 38.1 times 2, which is 76.2, which is the pitch radius of my gear times 2. I'm working with two identical gears, so I just simply multiplied that by 2. In your case, it should be the pitch radius of gear 1 plus the pitch radius of gear 2. I have the shaft now fully constrained. You can confirm that from the status over here as well. And now I can add the second gear. In my case, I'm pulling the same gear again. So I'm using multiple copies of the same part. This is an identical gear. And I'll start adding constraints. The first constraint I'll add would be the same one as what I did for the previous part, where I'll have it be 20 mm from this surface. Uh, okay, let me see. Let's put minus 20. So I think it might have been more than 20, but to not go through that hassle, what I'll do is that instead of using this surface as my reference from the assembly, I'll remove that reference and I'll use this face of the gear and I'll make them coincident, because that's what I want. I want them to be at the same plane. So that's the first constraint that I've added. It's still partially constrained. It can move in this direction, this direction. And the second thing I want to do is to mount it onto this shaft. So for that, what I'll do is that I'll select the axis over here and select the axis over here. With one trick that you can use in Creo is that instead of trying to find the axis, select any curved surface and Creo automatically selects its axis. So I'll select this curved surface and I'll select this curved surface, and Creo automatically selects their axes, and if I select the coincident constraint, those two axes have been made coincident. If I allow assumptions, which means that my part can rotate, then the part is now considered fully constrained. But for now, I won't allow assumptions, and I'll show you why I did that. I did that because I want to be able to move my gear. So I can't move this gear because it's fully constrained, but I can move this gear. Later on, we'll see how we can establish a motion relationship between two gears so that when you move this gear, the other gear moves as well. That's coming in a few videos. But for now, what we'll do is that we'll approximate a position where these two teeth just intersect. I want you to not have them not be touching at all. Just make them touch slightly, and there is a region for that. And uh, this is the kind of assembly that we wanted. There's just one last thing which is left. For your assignment, you'll have to make a key and a keyhole for the second gear as well. But one thing that I want to highlight, a very useful tool in Creo assembly is that it can tell you while you're assembling things if there is any interference, because eventually you might want to manufacture those parts and you want to confirm that your parts are dimensioned appropriately and they won't interfere during assembly. So for that, if you go to analysis and you perform a global interference check, global interference, go with the default settings, uh, preview, it highlights all the regions, all the areas where there is interference happening. So this gear is cutting into this gear slightly on these two teeth. If you move things around, re-perform the interference check, you might be able to see that there is no interference. But I want you to have some interference. Take a picture of that and share that in your report as well. Something similar to this. And yeah, that's your assignment. You'll have to color parts appropriately. Go to each part, select this part. Let's say that I want to color the second gear a particular color. I'll give it a white color. I might want to color the first gear brown. Uh, Color different parts differently. Each part should be the same color so that I can see and confirm that the parts are made independently. So for example, if I change the color of my base plate, not only does the back turn blue, but the shaft, which is a part of that same part file, turns blue as well, while this shaft doesn't because it's a separate part file. Uh, when you're done with your assembly, you have to package that, and remember that the assembly is just a platform where individual parts are being imported and displayed with particular orientation. So you need to have those individual parts available. So that go to file, save as. Uh, if you save an assembly, the individual part files are not always they're not by default carried over. So save it as a shift file, and when you transfer the shift file to anyone, the individual part files plus the assembly file, they'll all be transferred, and that's how I want you to submit your assignment. Thank you for watching this video. Sorry they were a bit long, but hopefully I've covered all of the important aspects of assembly, and in the next videos we'll start seeing how we can make our gears mesh and make them move, and then you'll use those for your motion analysis. Thank you.